Hello guys, hello Miss Fitri. My name is Artha Gracia Sitompul. I'm from XI.1 SMA Plus Negeri 17 Palembang. Now I'm going to explain about wave behavior. Happy watching! Wave behavior. So in this video, I want to explain about wave behavior. There's reflection, refraction, diffraction, interference, constructive interference, destructive interference, and the last is Doppler effect. First of all, I want to explain you about wave interaction. Wave interaction is when a wave meets an object or another wave, or when a wave passes into another medium. The examples are reflection, diffraction, refraction, interference, and resonance. The first is reflection. Reflection is when a wave strikes an object and bounces off. Common examples include the reflection of light, sound, and water waves. Okay, you can see the picture. There's our incident beam, normal line, and then reflected beam. And also there's our specular reflection with smooth surface, and then diffuse reflection with rough surface. You can see the difference of the rows. Okay, reflection is also when a wave bounces off a surface that it cannot pass through. You can see the picture. There are also angle of incident and angle of reflection. Okay, the second is refraction. What is refraction? Refraction is bending of waves when passing from one medium to another, caused by a change in speed. When slower or more dense, light bends toward the normal. You can see the picture. And then when faster or less dense, the light bends away from the normal. Okay, the refraction also the bending of a wave as it enters a new medium at an angle. Refraction depends on, first, speed of light in the medium, and then wavelength of the light, shorter wavelengths or blue band more. Example. Okay, you can see the picture. When we see the fish in the pond, what we see is the shadow of the fish, even though the fish are actually in a different position from their shadow. This phenomenon occurs due to the effect of refraction. This refraction occurs because of the difference in the refractive index between the air and water medium, where air has a lower medium density than water, so that the refractive index of water is higher than air. The other examples of refraction are a bending of sun's rays as they are entire drops forming a rainbow, and then also the prism. When white light enters the prism, the different wavelength or light are refracted. And also glass. Glass is a perfect everyday example of light refraction. Looking through a glass jar will make an object look smaller and slightly lifted. Okay, next, the third is diffraction. What is diffraction? So diffraction is the bending of wave as it moves around an obstacles or passes through a narrow opening. You can see the picture. An example of diffraction is when a water wave hits a boat and bends around the boat. The waves after the boat are changed or diffracted. Okay, the fourth is interference. So what is interference? Interference is the interaction of two or more waves that's combined in a region of overlap. You can see the picture. Okay, one of the best examples of interference is demonstrated by the light reflected from a film of oil floating on water. Another example is the thin film or soap bubble, which reflect a spectrum of beautiful colors when illuminated by natural or artificial light sources. Okay, there are two types of interference, that is constructive, is brighter light, and then destructive, it's dimmer light. You can see the difference. Okay, next, constructive and destructive interference. So both are caused by two or more waves interaction, but constructive interference combines the energies of the two waves into a greater amplitude. And destructive interference reduces the energies of the two waves into a smaller amplitude. Okay, the example of constructive interference is two speakers playing same music while facing each other. At this time, music will appear louder and powerful as compared to music played by a single speaker. And then the examples of destructive interference is, the first is gravitational waves of a specimen, and then light beams demonstrate, and the last is moving electron and radio waves. Okay, the last topic is Doppler effect. So what is Doppler effect? Doppler effect is a change in wave frequency caused by movement of sound source, motion of the listener, or both. One of the most common examples is that of the pitch of a siren on an ambulance or a fire engine. You may have noticed that as a fast-moving siren passes by you, the pitch of the siren abruptly drops in pitch. At first, the siren is coming towards you when the pitch is higher. Okay guys, that's all about my explanation. I hope this is useful. Sorry for all my mistakes. Thank you for watching. Bye bye!